you to this material science class. So today we are going to concentrate over heat treatment processes. Whenever certain quality or characteristics is to be developed in a particular metal, then the metal is heated at different ratings and then it's cooled at different ratings. It's heated to elevated temperature and then it is cooled at different ratings, means we can get different properties in the material. That's called as heat treatment processes. So in order to get strength, in order to improve the strength, or in order to improve conductivity, or in order to improve elasticity, in order to improve hardness, and in order to get such mechanical properties for proper application of the material in engineering field, the heat treatment processes are carried out. So in the pre-treatment processes, the important heat treatment processes are annealing, normalizing, hardening, and pack carburizing, and so on. And in the case of annealing process, the main purpose of this process is to soften the metal. Soften the metal means to decrease the hardness. Hardness should be decreased in order to apply the various forces, and in order to withstand the metal with various forces, then the material should be softened. For softening purpose, the annealing process is performed. In the annealing process itself, there are different types. Maybe full annealing or sub-annealing or normal or spiralizing, and so on. And in the case of full annealing, the metal is heated 50 degrees centigrade above the upper critical temperature. Upper critical temperature is specified in iron carbon equilibrium diagram. So it's heated up above 50 degrees centigrade above the upper critical temperature, and then it's cooled very slowly by just switching off the furnace when the article is placed inside the furnace. After cooling, the articles are taken out and the articles will get the softness. In the article, hardness will be decreased, and that's called as full annealing. Generally, the full annealing is carried out in the case of high carbon steels and medium carbon steels. So here, by this process, hardness and tensile strength of the material can be increased. And the next one is sub-annealing. So in the case of sub-annealing, the metal is heated just below the lower critical temperature, and it's heated such that austenite is not formed. So whenever the metal is heated above lower critical temperature, austenite begins to form, and the austenite is completed. The formation is completed when the temperature attains the upper critical temperature. And above upper critical temperature, the metal will be containing austenite fully. Therefore, in the case of sub-annealing, it's heated just below the lower critical temperature so that austenite is not formed. Then it's cooled slowly by switching off the furnace when the articles are kept inside. And then after cooling, the materials are removed, and generally this process is carried out for low carbon steels. And in this method, the material can be brought into stress-free condition. So for certain processes, stress-free condition is desired. Therefore, in order to get a stress-free condition, this process is carried out. But actually, the metal is softened, and the metal is also prepared for different other heating processes. Continuously, this process is carried out, and the new grain structures may be formed. The ductility is also improved, and the metal is softened for the mainly. This is called sub-annealing. And the next one is spiralizing. Spiralizing is nothing but the metal, the thin or very small globes are formed. Globes means small spheres are formed in the metal. So it's this process is called as spiralizing. Spherical grains are formed. The grains become in the form of globes, in the form of spheres, thin, very small spheres. So for getting this thing, the metal is heated up to 700 degrees centigrade, and then it's kept at that temperature for about 7 hours, and then it's cooled very slowly just by switching off the furnace, and the metals are removed after cooling. Then due to the formation of the spherical grains in the metal, the mechanical properties may be improved. The toughness of the material can be improved. So for such purpose, this this spiralizing process is performed. This spiralizing process, whenever it's kept for 7 hours in the 700 degrees centigrade temperature level, then thermal oscillations take place, and due to thermal oscillations, the grains are collided with each other and they are brought to the spherical forms, and that results in the machinability improvement. The property machinability is increased by this process. So, and the next one is the isothermal annealing. In this process, the metal is heated up to 600 degrees centigrade, and then it's kept at the temperature for about 2 hours. And in that metal, in that steel, a perlite is formed. So perlite is formed due to the formation of perlite. Mechanical properties are improved. So then after 2 hours, it's cooled slowly just by switching off the furnace, and then after cooling, it's removed from the furnace. Generally, this type of process is performed for low carbon steels and alloy steels. The next heating process is normalizing. Normalizing, in order to improve the mechanical properties, machinability, and such properties, this normalizing is performed. Normalizing is heated above 50 degrees centigrade, above the upper critical temperature, and then it's cooled quickly in the removing the articles from the furnace, and is kept in the airflow. So in the airflow, it's cooled. In the case of annealing process, the metal should not be taken out of the furnace immediately after the heating. It must be cooled in the furnace itself just by switch off the furnace. But here, in the normalizing case, the materials are removed from the furnace after heating, and they are kept in the airflow. So flow of air that removes the heat gradually. So the normalizing process, in this normalizing process, machinability is mainly improved, and this method is economical and is suitable for large castings and forgings. The next one is hardening process. The metal is heated to above upper critical temperature and then cooled quickly, very quickly, by quenching the metal into water baths. It must be cooled in water. Then the very fast cooling takes place. Due to fast cooling, due to quick cooling, martensite is formed. Martensites are needle-like grains. In grain structure, it becomes like needles. When you view through a microscope, you can see the needle-like structures. So due to formation of martensite, hardness is increased. So in order to improve the hardness, this hardening process is performed. But at the same time, whenever the hardness is improved due to quick cooling, the other defects like distortion, defects like crack formation, so these things may take place. These difficulties can be overcome by performing the tempering process immediately after the hardening process. Tempering process is nothing but reheating the metal to different temperatures, and then it's cooled in the air. So whenever it's heated to very high temperature to about 600 degrees centigrade and so on, then it's cooled. It's called a high temperature tempering process. High temperature if it is heated up to 400 degrees centigrade, then it's cooled. It's called medium temperature tempering process. If it's cooled up to 200 degrees centigrade, then it's cooled. Then it's called as low temperature process. Low temperature tempering process. So generally, the low temperature tempering processes are performed for cutting tools, measuring tools, and so on. And for medium temperature tempering process is performed for springs, simply for springs and coils. And high temperature tempering processes are mainly performed for high carbon steels. So In this way, the hardness can be improved, and at the same time, defects can be removed by tempering process, which are performed immediately after hardening process. These are the important hardening process. Apart from these things, whenever the metal is to be hardened, the surface itself, while the inner portion is not hardened, that's called as case hardening. Surface part மட்டும் hardness இருக்கணும், உள்ள inner part வந்து soft இருக்கணும், அந்த மாதிரி. Because whenever the metal is subject to immediate impact load, it must withstand the impact load. So in order to withstand the impact load, the inner part must not be hardened, it must be soft. Whereas in order to prevent the wear and tear, in order to protect the metal from wear and tear, the outer surface must be hardened. So for such purpose, the carburizing process is performed. Pack carburizing, it's called pack carburizing. So in the case of pack carburizing, the metal is taken along with limestone, charcoal powder in a metallic container, and then sealed with clay, then heated in a furnace up to 850 degrees centigrade to 950 degrees centigrade, in the temperature range, and then it's allowed to be heated to be in the furnace at the same temperature for about a definite period according to the thickness of hardness required. So then after the particular period of time, it's removed, and the surface part alone is hardened for a particular desired depth, and while the inner part remains soft, inner part is not hardened. Then liquid carburizing, another method. In this one, sodium cyanide solution is taken and heated to 800 degrees centigrade generally, or 850 degrees centigrade generally, and then the articles which are to be case hardened are suspended inside the solution, and then it's heated up to this one. It's kept at a particular time, depending upon the thickness of hardness required. Then it's removed from the solution, and the surface part alone is hardened. In that case, the quality is superior, because in the case of pack carburizing, the carbon penetrates into the metal surface in order to improve the hardness. But here, this is a solution. Therefore, the surface part is smooth rather than the pack carburizing. Pack carburizing, smoothness cannot be expected, but here the smoothness can be expected. And also in the case of gas carburizing, when the metal is heated in the furnace, in the presence of some gases which may be rich in the carbon or nitrogen, whenever it's heated in the presence of the gas which contains carbon, the carbon contents penetrate into the surface of the metal, and the surface of metal is hardened. So before penetrating inside, the furnace is switched off, it's taken out. So gas carburizing. Whenever the metal which is rich in nitrogen oxide and so on, then the nitrogen penetrates into the surface part becomes metallic nitride, and is also hard. So hardness can be improved like this in the surface, and this is called nitriding process. So this way the surface part can be hardened. And in the case of induction hardening, the metal is placed inside a coil and current is passed through the coil. So magnetic flux may be produced. And due to interaction of magnetic flux, eddy currents are produced in the metal. So this eddy current increases temperature, and it's heated up, and the metal gets heated up. After allowing the eddy current for a particular period, then the switched off, and the power is switched off, and the metal is removed from the coil and cooled quickly by spray of water, and the surface part alone is hardened. So before the heat entering into the inner surface, the metals are removed from the coil. So induction hardening has good quality, because the metal surface is not converted into carbide or nitride form. Also, for simple purpose, for economical purpose, the metal surface may be heated by oxygen. just not melted but just heated, and then it's put in water, spray of water, or just you are injected into water, and it's in the outer surface, the water set will be formed, and inner surface remains soft. It's called as flame hardening. So these are important heat treatment processes we have performed for getting desired properties in the metal. So in the examination, you can expect one question from heat treatment process. So study the notes, and if you got any doubt, please contact me through my WhatsApp or through my cell number, through my mail ID. Or if you can come directly to the institute, come and clear your doubts. Thank you.